The A320 family is equipped with, like most engines today, this engine comprises a low-pressure LP compressor stage, a high-pressure HP compressor stage, a combustion chamber, and a turbine stage. The front fan, the low-pressure compressor, and the low-pressure turbine are connected to form the low-speed rotor, N1. The high-pressure compressor is connected to a high-pressure turbine to form the high-speed rotor, N2. The high-speed rotor drives an accessory gearbox, which is located at the bottom of the fan case. The combustion chamber is equipped with two igniters, called A and B. Each engine is equipped with a full authority digital engine control system, FADEC, which provides complete engine management. For redundancy, each FADEC has two channels, A and B, one active and one in standby. Each engine is equipped with reversers, which are hydraulically actuated. The engines are controlled by thrust levers, which are located on the center pedestal. These two levers control the reversers. The autothrust can be disconnected with either of these red push buttons, which are called instinctive disconnect push buttons. The controls for engine starting and shutdown are located on the center pedestal, just behind the thrust levers. The engine master switches and the engine mode selector enable the pilots for engine automatic and manual starting, engine ventilation, dry cranking, and engine shutdown. Once the engines are running, the mode selector can also provide continuous ignition. Each engine has a fire and fault light. This panel will be explained in detail in the normal and abnormal operation modules. On the overhead panel, there is an additional panel which is used for a manual engine start. This will be seen later in the manual engine start module. Engine controls and parameter indications are displayed on the engine warning display and system display ECAM pages. The engines are also equipped with a fire protection system. You will see the complete operation of this system in the fire protection chapter. Let's look at the things that you need to know about the engines during normal operation. We will start with a preliminary cockpit preparation. You are in the cockpit. The pilot non-flying ensures that all required checks written on the Standard Operating Procedures (SOP) are performed before the application of electrical power. Engine, landing gear and wiper controls have been checked. External power is available. It's now time to power the aircraft. Power the aircraft. The FADECs are powered automatically for 5 minutes after the electrical power is applied to the aircraft and provide some engine indications on the engine warning display. After 5 minutes, the FADECs shut down automatically and all the engine indications change from normal to amber. Let's assume that all checks have been performed by the pilot non-flying. It's now time for the exterior inspection. On each engine, we check that the oil fill access door is closed, and we verify the condition of the drain mast and the absence of leakage. We verify that the fan cowl doors are closed and latched. We verify the condition of the engine inlet and fan blades. On the right side of each engine, we check that the vent inlet is clear, the pressure relief and start valve handle access door is closed, the pylon access panel is closed. On this side, we also check that the turbine exhaust is clear. We are now back on the flight deck for the cockpit preparation. Verify that on the engine start panel, the Master 1 and Master 2 switches are off. The mode selector is in the normal position. The thrust levers are in the idle position. Cockpit preparation is complete. The passengers are on board. The APU is running, and we are now ready to start the engines. We will start the engines using the automatic engine start procedure. During the start sequence, all the engine parameters are monitored, controlled and protected by the FADECs. In order to start the engines, the engine mode selector must first be switched to ignition start. Start the engines. When ignition start is selected, the FADECs are powered again. This is indicated on the engine warning display by the indications which change from amber to normal. On the system display, the ECAM engine page is automatically presented for more engine indications. Let's look at the engine indications specifically. The first indications on the engine warning display is the N1 of each engine. Both indicators are identical. The green needle indicates the actual N1. This value is also displayed digitally. The white circle represents the N1 corresponding to the thrust lever position. The amber mark represents the maximum N1. This is the N1 that would be produced with the thrust levers fully forward. The beginning of the red area represents the max permissible N1. The rest of the arc represents the exceedance area. On the right side of the engine warning display, the thrust limit mode and N1 rating limit are displayed. This will be explained and demonstrated as the mode changes later in the module. The next set of indicators display the exhaust gas temperature, EGT, of each engine. The green needle indicates the actual EGT. This value is also displayed digitally. The amber tick indicates the maximum EGT, max EGT. Since the max EGT is different for starting, toga, flex, the tick moves automatically depending on the phase of operation. Note, the amber tick is not displayed during takeoff. The N2 indication is only displayed digitally. The fuel flow is displayed digitally for each engine. Let's look now at the indications on the ECAM engine page. The first indication displayed is the fuel used by each engine. Notice that there is a fuel used indication and the engines haven't been started. This is because this value is frozen at engine shutdown and reset on the ground at engine start. The next indications are the engine oil quantity, the oil pressure, and the oil temperature. Vibration indications are displayed on the right-hand side of the ECAM engine display. There are additional indications displayed during engine start on the ground. They are only displayed when the engine mode selector is in the ignition start or crank position. They are the start valve position indication, the air pressure available for start. We will start the engines using the available APU bleed as indicated on the memo and the pressure indication at the bottom of the system display. We start engine 2 first, because the yellow hydraulic system engine-driven pump is on engine 2, and the yellow system supplies park brake pressure. Switch on engine 2. The corresponding start valve opens. This is indicated by the start valve indication changing from green cross line to green in line. The fuel used is reset to 0. On the engine warning display, N2 increases. It is displayed on a grey background. On the ECAM engine page, the oil pressure increases. At 16% N2, an igniter is powered. The active igniter is indicated by a letter, A or B, on the ECAM engine page. Note, the igniters alternate on successive starts. At 22% N2, the fuel starts to flow. We can see the indication on the engine warning display. 15 seconds after fuel is on, EGT and N1 increase. At 50% N2, the start valve closes and the ignition is switched off. Notice on the ECAM engine page, the start valve is closed and the igniter indication disappears. N2 continues to increase. At approximately 58%, it stabilizes and the grey background disappears, indicating that the start sequence is finished. Engine 2 is now running and all its parameters have stabilized. Notice the thrust limit mode has changed to Toga, and today the N1 rating limit is 94.1. As soon as one engine is started, the gross weight is displayed on the ECAM engine page. Let's start engine 1 now. We will show you the full sequence without stopping. Start engine 1. Start valve opens. Fuel used is reset. N2 increases. Above 16% of N2 and igniter is powered. Above 22% of N2, fuel flow begins. EGT increases. When N2 reaches approximately 50%, the start valve closes and ignition is switched off. At about 58%, N2 stabilizes and the grey background disappears, indicating that the engine 1 start sequence is finished. For both engines, all parameters have stabilized. The last action is to switch the engine mode selector to normal. Switch the engine mode selector to normal. On the system display, the ECAM engine page is replaced by the ECAM wheel page. Note, after start, to avoid thermal shock, it is recommended that the engines are operated at or near idle for at least 2 minutes. This ends the engine automatic start sequence. In this module, we will see how to operate the engines during the various phases of a flight and familiarize you with their functions and indications. It only requires a small increase of thrust to get the aircraft moving. After this, idle thrust is usually enough to keep it taxiing. On ground, thrust control is entirely conventional. The thrust lever position determines the amount of thrust. The thrust levers can be moved manually over the entire quadrant. They do not move on their own. They have 6 positions on the quadrant: idle, climb for maximum climb thrust, flex MCT, one detent serving 2 functions. Flex is used for reduced takeoff thrust. MCT for maximum continuous thrust is used for one engine out operations. Toga for maximum takeoff or go-around thrust. Idle reverse for idle thrust when reverse selected. Max reverse for maximum reverse thrust. Thrust control can be achieved in 2 ways: manually using the thrust levers as in any conventional aircraft, automatically when the auto thrust is active. Note, the FADEC prevents the thrust from exceeding the limit for the thrust lever position in both manual and automatic modes. Let's look at the indications for takeoff. On ground, the thrust limit mode is flex or toga. The selected mode is displayed in the upper right-hand corner of the engine warning display. Toga represents the maximum thrust available from the engine for the actual outside air temperature, OAT, of the day. The N1 rating limit, displayed alongside the selected mode, indicates the related N1 value. Flex is used for a reduced takeoff thrust. To achieve the thrust reduction, an assumed temperature or flex is used, for example 45 degrees Celsius. The flex temperature is displayed beside the N1 rating limit. This means that the engines will perform as if the takeoff was made at full power with the outside air temperature at the flex value. The result is that the actual takeoff thrust is reduced, which helps to prolong engine life. Flex takeoff will be discussed in more detail during the performance part of the course. Today, we will carry out a reduced thrust flex takeoff, as this is what you will do normally. The pilot flying progressively adjusts engine thrust in 2 steps. The first step is to move the levers from idle to approximately 50% N1. Click on the thrust levers to apply the thrust. When 50% N1 is reached, flex takeoff thrust is applied on both engines by moving the thrust levers to the flex detent. Continue to apply the takeoff power. When you reach the flex detent, the pilot non-flying checks that the indicated N1 is the same as the N1 limit. The FADEC will maintain takeoff thrust and monitor for overspeed and temperature during takeoff. Note, toga thrust is always available by moving the thrust levers to the toga detent. At thrust reduction altitude, move the thrust levers to the climb detent when the flashing climb prompt appears on the Flight Mode Annunciator, FMA. Note, auto thrust will now be active. Select climb thrust. When the levers are in climb position, auto thrust is engaged automatically. The thrust limit mode turns to climb and the N1 rating limit changes. At 1500 feet above ground level, the ECAM engine page is replaced by the ECAM cruise page on the system display. Watch the N1 indicators. When the N1 value changes, an N1 command arc is displayed in blue, from the current N1 to the new N1 value. Note, it is only displayed with auto thrust engaged. When the new N1 value is reached, the command arc disappears. Let's see it one more time closer. The cruise page displays the fuel used for each engine, the oil quantity for each engine, and the vibration rate for N1 and N2. During cruise, descent and approach phases, auto thrust is normally active, and the thrust levers remain in the climb detent. In flight, if both engines are at idle, an idle indication appears. It flashes for 10 seconds and then remains at steady green. Note: there is a slight difference between flight and ground idle. If heavy rain or turbulence is expected after takeoff or during initial approach, it is recommended to select continuous ignition. Continuous ignition can be selected manually by moving the mode selector to the ignition start position. To demonstrate this indication, select continuous ignition. When selected, the message Ignition is displayed on the engine warning display memo. Note: continuous ignition is selected automatically when engine anti-ice is in use. No switching action is required. During landing, the pilot moves the thrust levers to idle. During landing, there is a call-out to remind the pilot. Select the idle position. After touchdown, reverse is selected immediately to help the deceleration of the aircraft. Apply the reversers. On the N1 indicators, REV appears in amber, indicating that the reversers are unstowed or unlocked. When the reversers are fully deployed, the REV indications change to green. As the aircraft speed approaches 70 knots, the levers should be moved to reverse idle. Return the levers to reverse idle. Now click on the levers to move them to reverse idle. In order to extend the useful life of the engines, it is recommended to leave the engines running for 3 minutes after using maximum reverse thrust. To shut down the engines, the corresponding engine master switches must be set to off. Switch off engine 1. The engine shuts down. On the engine warning display, the fuel flow indication is 0. The EGT decreases. N1 and N2 decrease. Switch off engine 2. Engines 1 and 2 are shut down. We will now see how to start the engines manually. There are several reasons why a manual start may be required, including low pneumatic pressure. The main difference between a manual and an automatic start is that the pilot controls the moment at which fuel and ignition are supplied to the engine. The FADEC only provides passive monitoring of the engine during the start sequence. This means that the responsibility for preventing an abnormal start remains with the pilots. Note: manual starts are completed using the procedure detailed in FCOM 3, Supplementary Techniques. The FADEC controls the closure of the start valve at 50% N2, the position of the high-pressure fuel valve, and ignition cutoff on the ground. On the engine warning display, all indications related to the engines are displayed in amber, as long as the FADECs are not powered. In order to start the engines, the engine mode selector must first be switched to Ignition Start. Start the engine manually. When the selector is in the ignition start position, the FADECs are energized and the engine parameters are displayed on the engine warning display. The engine ECAM page is displayed automatically. We will start engine 2 using the APU bleed. The engine manual start push-button switches control their respective start valves. To start engine 2, raise the guard and select Engine Manual Start 2 push-button switch. Start engine 2. On the engine manual start panel, ON light illuminates blue on the Engine Manual Start 2 push-button switch, indicating that the start valve has opened. On the ECAM engine page, the corresponding start valve opens. On the engine warning display, N2 increases. On the ECAM engine page, the oil pressure increases. N2 continues increasing to max motoring speed. At max N2, at least 20%, select Engine 2 master switch to ON. Note: the pilot flying should start his chrono when he selects the engine master switch to ON. Select Engine 2 master switch to ON. On the ECAM engine page, the fuel used is reset to 0. Both igniters are on. On the engine warning display, fuel flow is increasing. When N2 reaches 50%, start valve closes and ignition stops. N2 continues to increase. At about 58%, it stabilizes and the grey background disappears to indicate that the start sequence is finished. The engine 2 is running and all its parameters are stabilized. It's now time to switch off the engine manual start push-button switch. Switch off Engine Manual Start 2 push. The manual start sequence of Engine 2 is finished. If required, Engine 1 can be started in a similar manner. When engines are running, remember to set the engine master switch to normal. This is a demonstration of an abnormal engine start. Start engine 2. No, to start engine, continue the start. As there is no ignition, the FADEC automatically shuts off the fuel, turns off the ignition and performs a dry crank cycle. Note, the start valve is still open. On the engine master panel, the fault light illuminates amber, indicating that the automatic start has aborted. The caution is activated and the associated failures are displayed on the engine warning display. Read the title of the failure. A new start is in progress, as displayed on the engine warning display. Now both igniters are powered. The fuel starts to flow. The new start has also aborted. A new message is displayed on the engine warning display. This time, the FADEC shuts the valve off once the dry crank cycle is completed. The new ECAM procedure asks the pilot flying to shut engine 2 off. We will do it for you. When the engine 2 master switch is off, the message disappears on the engine warning display, and the fault light is switched off. We will assume that the procedure is complete. Now let's see another engine abnormal operation. You are the pilot non-flying. Everything is normal. We are in cruise. The ECAM engine page is automatically displayed. Notice that the engine 1 oil pressure is pulsing. This is advising you that the oil pressure is in the lower end of the normal range. The red warning and associated procedure are displayed on the engine warning display. The engine 1 oil pressure indicator is displayed in red, indicating that the oil pressure is too low. The procedure is to shut down the faulty engine. You will practice this procedure in the simulator. We will assume that the procedure is completed. Now let's see another engine abnormal operation. You are on ground. Everything is normal. Observe that if the oil temperature is above the normal range, the oil temperature indication pulses green. When indication is beyond the normal operating range, the oil temperature indication becomes amber. You will practice this procedure or one similar in the simulator. Let's look briefly at some other engine abnormal indications. The amber warning is displayed on the engine warning display. Read the title of the failure. The ECAM engine page appears automatically. The oil filter indication is displayed, and the corresponding oil filter is indicated by clog in amber. The same kind of message can occur with the fuel system. The amber warning is displayed on the engine warning display. The ECAM engine page appears automatically. The fuel filter indication is displayed, and the corresponding fuel filter is indicated by clog in amber. We will now look at some examples of other abnormal indications, which can be displayed on the ECAM engine page. During the start sequence with the start valve opened, if the upstream bleed pressure is below the normal range, the indication becomes amber. Note, this may happen during start, but the pressure usually returns to normal. If the pressure remains low, await ECAM instructions. The alpha floor function was explained in the AutoFlight chapter. However, observe that the engine N1 indications are unusual, as the achieved N1 is greater than the thrust lever limit and corresponds to toga thrust N1. We will see a demonstration of an engine EGT overlimit in cruise. You are the pilot non-flying. We are in flight and everything is normal. On engine 2, EGT value is increasing. Above the normal range, the EGT needle turns amber and pulses amber, while the associated digital value remains steady green. You heard and saw the master caution. The ECAM warning and associated procedure are displayed on the engine warning display. The temperature has continued increasing. The EGT needle and digital value have turned red. The needle pulses red, while the associated digital value remains steady red. The only ECAM action is to move the thrust lever. We will do this for you. The EGT engine 2 value indication changes from red to green. ECAM actions completed. If the EGT exceeds a certain value, a red mark is displayed at the max achieved value. The over-limit mark will disappear after a new takeoff, following a maintenance action. A similar indication will be displayed in case of N1 or N2 over-limit. Above the normal range, the needle turns amber and pulses amber, while the digital value remains steady green. If N1 exceeds a certain N1 and enters the red arc area, the N1 pointer turns red and pulses, while the digital value becomes steady red. An ECAM warning will be generated. A red perpendicular line marks the maximum achieved value and remains displayed until a new engine start on the ground following a maintenance action. When N2 exceeds a certain value, the digital value turns steady red. A red cross appears next to it and an ECAM warning is generated. We will now see another engine abnormal indication on the engine warning display. A discrepancy is detected. An appropriate ECAM warning is generated. An amber check message underneath the affected parameter indicates a discrepancy between the value displayed on ECAM and the real one. The same indication can be found for N1, N2 and fuel flow. Moreover, when i.e. N1 or N2 parameters are degraded through a sensor fault, the last digit will be displayed dashed amber.